Today I'm going to take a look at AutoHotkey. AutoHotkey is a scripting language for Windows made for automating any kind of task that involves the keyboard and mouse, and executing commands, setting macros, cheating on games, and many other features. Its main usage is the setting of hotkeys, hot strings, to execute a piece of code defined for that key. So here you can see how easy to set up hotkeys or hot strings and executing commands with run. Here's another example where you can get and set the contents of the clipboard and send keystroke very easy. You can also interact with the script by creating graphical user interfaces, which is a built-in feature of the language. Very useful to configure your scripts. You can see in this example that you can declare variables like any other scripting language, but it also has arrays, control flow, different ways to loop, and even object-oriented programming support. It pretty much has everything a general-purpose programming language should have. So the origin of AutoHotkey is actually very interesting. It starts out with another very similar programming language called AutoHotkey. So AutoHotkey started in 1999 when its developer, Sean Bennett, wanted to automate the installation of Windows, and there wasn't any reliable way to do that. Fast forward to 2003, Chris Mallet made a proposal to integrate hotkey support to AutoHotkey, but it didn't get much attention from the community, so he built a new program from scratch based on AutoHotkey, and that's where AutoHotkey came to life. What's interesting is that in 2005, AutoHotkey went from being open source using the GPL license to closed source because apparently there were several projects that leaked AutoHotkey code to their own projects without giving proper credit, violating the GPL license. And I think it's understandable because I will also be pissed if someone took my code without giving me credit and completely disregarding the license. Anyway, going back to AutoHotkey, Windows it supports creating graphical user interfaces. I decided to use Creative to make a game. So let's see how we can call C code from AutoHotkey. To execute C code, AutoHotkey provides a simple but powerful function called DLL call, which can be used to call any function compiled in DLL files. So to organize the code, I grab the related functions I use into a class and set the function as methods. All you have to do is pass the function you want to call and the parameter preceded by the type. Functions that take ints, floats, or strings are defined like this, and that's it. But when it comes to passing C structs, it's a bit more complicated. Let's take a look at, for example, this function draw rectangle rect, which takes a rectangle and a color. Here I created a class to handle the color struct, which is pretty simple. Just pack the RGBA values into a single integer by shifting the values, and that's it. We can pass that integer to the C function. I also added a getter and a setter to make it easier to change the individual colors. When we get or set color and the variable in square brackets and pass the RGB or A as the color, that value is inserted between the percent signs. So you don't have to specify the different values, which I think is a really nice feature. The rectangle object is not as simple as the color. Here I have to create a buffer object, which is a block of memory that calls the values. You have to provide the number of bytes to allocate, and each float value is 4 bytes, and we have to sort the x, y, width, and height, so it's 16 bytes, and then use numput to set the values with their corresponding offset. When I try to pass the buffer to the C code, it crashed. And this is because almost all of Rayleigh functions take parameters by value and not by reference. Fortunately, the easiest fix was to go to Rayleigh source code, change the parameter to a pointer, and change all the lines where the code access to the struct from a dot to an arrow. Recompile the whole library, replace the DLL, and boom, now it works. The second thing I had to change was the way textural load, since I needed a pointer to the texture. I simply allocated memory and returned the pointer. Now that I can draw rectangular images, I'm ready to make the game. Here I made a top-down mini-golf game. It consists of 5 levels, each with different mechanics. A regular map, a map similar to Frogger, spikes, a map with 2 holes and ice, and a map with portals. The game can be broken down into 4 main parts. The ball movement, checking when the ball collides with the walls, checking when the ball enters the hole, and checking when the ball collides with a special object like cars or spikes. First, when the user clicks, the aiming mode is set. The force the ball would be hit is defined as the distance between the mouse and the ball multiplied by 1.5. Then we get the angle between the mouse and the ball, subtracted by 180 degrees, so the line is drawn in the same direction the ball would move. When the user clicks again, the moving mode is set. When the ball is moving, we have to check for different intersections. So first is the intersection with any hole. Simply check the distance between the ball and any hole. And if it is less or equal than the hole radius, then drop the ball inside the hole and finish the level. Then we have the intersection with any portal. Again, it's as simple as checking the distance between the ball and the portals. In this case, there's an extra variable to check when the player touches the portal for the first time, to avoid teleporting back and forth. The portal also increases the force of the ball. Then we get the type the player is currently in. This is wrapped in a try-catch block because right now there's a problem with the collision where the player can't go out of the grid, which will crash the game. So this way it is possible to prevent that from happening. With the tile, it is possible to check if the player is touching lava, spikes, or a pit, in which case we simply reset the game. Finally, we subtract the friction from the force and then we move the ball. For the movement, I get the nice running tiles and check for collision. The ball new angle is 2 times the angle of the wall minus the angle of the ball. If the ball touches 2 walls, I use the middle angle between the 2 walls. So here I made a visualization of the way I get the collision between the wall and the ball. So first, get the x and y components of the wall, called dx and dy, and the components of the ball, which are called ex and ey. Then we calculate the dot product, which is the sum of the multiplication of the components. We get the wall length, divide the dot product with the length, and we get the projection of the ball vector onto the wall. Then we get the x and y position of the closest point to the ball inside the wall, represented by this cyan circle. Finally, measure the distance between the closest point and the ball. If the distance is less or equal than the ball radius, then there's collision. And that's it. For the second level, if the ball collides with any core, the game restarts. The log simply adds an offset to the movement of the ball, so it moves with the log. As I said before, each tile has its own friction. In this case, the street tile has slightly less friction, and this sand tile has much more, so the ball stops immediately. The third level has tiles that switch between spikes and no spikes. When the ball touches the pipe, the game resets. The fourth level has 2 holes. Before starting the game, when the fake hole is detected, the real one is randomly set. In the last level, the player can shoot portals only when the ball is moving. The green dots are drawn one by one before reaching the mouse or a wall. To move between the portals is simply subtracting the difference between the current position and the target portal, plus 32, so the player spawns in the middle. And that's because each tile is 64 by 64. Finally, I want to show the program I made to make the maps. I don't really know how people store grid maps, but what I do is to set each tile with a specific character in the ASCII table, starting from uppercase A, which is 65, all the way up to underscore, which is 95. Making the bump is as simple as getting the X and Y position of the mouse when clicking and convert to the word position to the grid position, and then replace the character with the selected tile's character. Saving the map is just writing that string to a file. And this is what I always do when I make gridded maps. So yeah, AutoHotkey is a very powerful script language capable of more than just creating macros and hotkeys. It helps a lot that AutoHotkey has a very simple syntax, which in my opinion is a bit close to Python's syntax. So people who don't have much experience programming have an easier time learning this language, and they could easily transfer that knowledge to Python if they wanted. So yeah, that's pretty much it about the language. Thank you very much for watching, and I hope you have a wonderful beginning of the year 2024.